Re- Hello, and welcome to Engineering Economics. I'm going to cover Chapter 12 on depreciation in one class, but it's going to be in two videos that I produce and two sets of lecture notes. And so I'm calling this Class 24A, which is going to cover sections 12.1 through 12.3 on depreciation methods. And again, I always recommend that when you go to Blackboard, go to the start page and go all the way down and look at the schedule, because it can change the schedule of assignments. Some people have asked me when the project is due, and that appears on that schedule of assignments at the bottom of the start here page. So for today's lecture, you need to have read pages 358 through 365 in your textbook, and then watch this video, and these lecture notes will be posted along with the video as usual. And if you want to make a good grade, you need to work as many problems as you have time to do. And hopefully that's a lot of them, in addition to the homework assignment. And so we're going to start with section 1, which is depreciation terminology. And depreciation is a term that means a reduction in value of an asset. That's a more general term. We're going to talk about book or tax depreciation also. Okay, so depreciation is also, from that standpoint, it's a tax deduction. So if you own an asset, the idea of it depreciating is not a good thought. However, the idea of taking a tax deduction which will allow you to pay less taxes, that's a great idea for most taxpayers. So it has two different meanings. One is a real depreciation that an asset that you own undergoes because of wear and tear or even just time, and the other is the tax deduction that you are allowed to take as what's called a depreciation allowance. And so we're going to talk about mostly the tax deduction part, and I describe that here on the second page of the lecture notes about real depreciation is a bad thing, book or tax depreciation is a good thing. So additional definitions. The first thing here, we've always dealt with P as a present value or the cost of something right now. And in depreciation accounting, that's called the original basis, B. Now, the original basis includes more than just the price tag of, say, a piece of equipment. It includes the delivery, installation, and may even include operator training, whatever is required to get that asset functional so that it can begin to produce income for this company or an individual. And we'll talk a little bit about producing income, because property is generally not depreciable unless it is purchased and used for the production of income. As an example, say you have a refrigerator in your house at home. You cannot depreciate that and take a tax deduction because of that refrigerator, assuming you're not using it as part of a business. However, a refrigerator, that same maybe model refrigerator that's in a restaurant that's trying to make money, is trying to produce income with that refrigerator, that is depreciable property. So it's the same asset, but in one situation, in a home, just to keep the food you want to eat cold, it's not depreciable. But in in a restaurant, it's certainly depreciable property. Okay, so property that's used for the production of income generally is depreciable property. So we talk about the first cost, or the original basis in depreciation language, so to speak. And then there's something called the book value. The book value is the original basis minus all the depreciation you've taken up to some point in time. So if I want the book value at time 3, which is really the end of year 3, then I would take the original basis at time 0, subtract the depreciation in years 1, 2, and 3, and I would get the book value at the end of year 3. The recovery period is the number of years the asset will be depreciated. It's not necessarily the number of years that you're going to use that asset. You may use an asset well beyond its depreciation life or its recovery period. So this recovery talks about recovering all your depreciation charges. A good example, say, of that situation, say you own the corner gas station and you bought a pickup truck to run errands or whatever. Part of that business is this pickup truck. A brand new pickup truck is 4-year depreciable property. I'm sorry, 3-year depreciable property under MACRS depreciation. So you will get to depreciate it actually over a 4-year period. We'll learn a little bit about half-year convention. If it's 3-year property, you depreciate it over n+1 years, using one of the methods of depreciation, actually the most common method. So bottom line is, you'll depreciate it over some number of years, but you may keep that pickup truck 10, 12 years, but it's just not depreciable after its recovery period is over. Okay, so what that would mean, though, is you probably depreciated the entire basis in the first few years, which is a good thing. You got a lot of tax deductions early on. The recovery period, the market value, is the estimated amount an asset can be sold for. Okay, at any point in time, its market value. We dealt with this in previous chapters, and sometimes that market value has really nothing to do with its book value or with its how much has been depreciated so far. Give you a case, maybe an example where the book value is going down because you're depreciating the asset, and yet the market value, what you could sell it for, is going up. Suppose you owned an apartment building in a very desirable part of Houston. The apartment building is probably going up in value, so it's not depreciating, it's actually appreciating, but you still can take depreciation every year. You can take a tax deduction even though the asset's not going down in value. So that's a very unusual, not all that unusual, but machinery generally doesn't follow that kind of a pattern, but real estate very well might. And real estate is depreciable property if it's used in your business. Now, if you just have a home that you go to after work, and you don't have any kind of a side business that you run out of that home, then your home's not depreciable property. It's not used for the production of income. It's just used for you to live in. Now, if you have a building that even if it's a house in a neighborhood, but you go there to, let's say, run a consulting company out of that building, well, then that building becomes depreciable property. So it has to be used for the production of income. Okay. The salvage value is the estimated amount an asset can be sold for at the end of its life or recovery period. Depends on what depreciation method you're using, and what the recovery period of that depreciation method is. The depreciation rate, D sub t, is the fraction of the first cost taken as a depreciation in year t. So if I multiply D sub t times the basis, the first cost, that will give me the depreciation in year t. Depreciable property is personal or real property used for the production of income. Now, personal property is essentially, as far as the tax laws go, anything that's not real estate. And of course, real estate or real property is real estate. Then we break personal property down into tangible and intangible. Tangible, the term tangible means that it can be touched. Okay, so if something's tangible, it can be touched. Tangible personal property is property that's used for the production of income and that can be depreciated, such as machinery, equipment. Tangible means it can be touched. So first of all, it can be personal property or real property and depreciable. And it can, if it's personal property, it's tangible. It's things like equipment, machinery, that sort of thing. Real property is tangible property that is real estate. Simple as that. Now, real estate generally consists of two things. Buildings or structures is one thing, and then land is another. Turns out that the tax law does not allow you to depreciate land. So if you bought let's say an apartment building and you're going to rent it out, it's a business, the land that you bought that apartment building is on is not depreciable, but the building itself is depreciable. So that's two different kinds of real estate. Land, not real depreciable. Buildings, yes. Intangible property, generally we don't depreciate. It means it can't be touched. Things like copyrights and patents, especially, those kinds of things. Now, the next term is called a half-year convention, and it assumes that when the year in which you purchase, install, and begin using a piece of equipment, that year, I mean, you might have purchased it and put it into production in January, or you might have done it in December. So rather than give you a whole year of depreciation if you just put it in service in December, it just kind of takes an average and says, look, the first year you put it in service, if we're using half-year convention, you get only a half a year's depreciation for it. And then what happens then is you get the other half in year n plus 1. So that's why in some cases, a property that has a recovery period of n years, it really is depreciated over years 1 through n plus 1, because in year 1 you get half a year's depreciation, you get the other half in year n plus 1. So that's what half-year convention means. So let's talk about some specific depreciation formulas and methods. The first method is very simple, used to be used a lot, but it's not much anymore. It's called straight line depreciation. Straight line basically means you get the same depreciation every year. And that's equation 12.1, and it says D sub t is the original basis B minus the estimated salvage value divided by the number of years that you estimate this asset will be used. Well, think about it. If you were the taxpayer, what would you estimate the salvage value to be to get this numerator to be as big as possible? Because if the numerator is big, that's going to make your depreciation big, right? Well, the basis is usually known because you have to buy the equipment. You know how much you paid it for it. It's on your books right there when you purchase order and so on and so forth. So the basis is not flexible. But what you estimate the salvage value to be is very flexible because it's going to occur in the future some point in time. So the estimated salvage value could be zero. You could say, I don't think it'll be worth anything. Okay, and then the number of years. Well, as the example with the pickup truck for the corner gas station, you would want to estimate that as small as possible to get this depreciation as big as possible. Okay, so you might only estimate 3 years or 2 years. Then I'll trade this pickup truck up and get a new one. Anyway, this is the formula, B my original basis minus estimated salvage value over estimated life. That's equation 12.1 for straight line depreciation. The book value after T years is BV sub T, and that's the original basis minus T times the depreciation. It turns out that if you're using straight line, the depreciation is the same every year. There's no T on the right-hand side of this equation, 12.1. So it's not a function of T. It's the same no matter what year you're talking about, for straight line only. Okay. So here's an example. An asset has a first cost of $50,000. That includes purchase, delivery, and installation and testing to make it operational. So that's all the cost to get it going, so to speak. It has an estimated life of 5 years and an estimated salvage value of $10,000. How much depreciation is taken in years 1 through 5? What is the book value at the end of year 3? Well, equation 12.1 says that the depreciation in years 1 through 5 is the same every year. It's straight line, that's what that means. And it's going to be the price, that's the $50,000, minus this estimated salvage value divided by the number of years, which we estimated to be 5. And so that'll be $8,000 a year. What's the book value at the end of 3 years? Well, after 3 years, you've taken 3 times $8,000 in depreciation, which is 24. We started with a $50,000 book value at time 0. So B is equal to the book value at T equals 0. And so we subtract that 24,000 from the 50,000 to B using this equation 12.2. We get 26,000 for that. The declining balance method is a more tax-friendly method than straight line because you get more depreciation in the first few years, and we know from the time value of money we would like to get more tax deductions, pay less tax now, pay maybe a little more later. Okay, and so in the declining balance method, we come up with something called the rate of decline, D. Okay, and D can be any number between 0 and 2 over n. That's the maximum value of D is 2 over n. When D is equal to 2 over n, we call that 200% or double declining balance, double rate. Why did we call it double rate or 200%? Well, look at the straight line method. Its denominator is its numerator is just the original price divided by n. So this is 2 times the original price over n, so to speak. Okay, so if you're using, for example, some assets you can't go that high, even though that's an overall maximum. Some assets are limited below that overall maximum. You could only use 150% declining balance. If that's the case, then this would be 1.5 over n. So that's what I'm showing here. So this is the equation 4 gives you the rate of decline, and it's generally between 1 over n and 2 over n. And the maximum, though, for any asset is 2 over n. And then the depreciation in year t then is d, that's this value, whatever it is, times the book value at the end of the previous year, bv sub t minus 1. And equation 2.6 provides both the book value in year t, bv sub t, okay? So if we know the depreciation, what's the remaining book value then? And that value is given by equation 12.6. bv sub t is equal to b times 1 minus d to the t power. And there's kind of other ways to write that. Equation 12.7 gives the depreciation rate in year t as a function of the first cost. So d sub t is d times 1 minus d to the t minus 1. And if I combine that with an earlier equation, I can get the book value, the depreciation as a function of just the book value. The original basis and this D factor, okay? And so if I do that, then I get d sub t is equal to d times b. This is some function of over n. Remember, it could be 2 over n, it could be 1.5 over n, or so on. And then this is unknown, and then 1 minus d to the t minus 1. That's equation 12.8. So we commonly use this equation to get the depreciation, and then we can use this equation up here to get the book value. So equations 8 and 6 are the most commonly used, I would say. The author talks about an implied salvage value because if you're going to depreciate an asset over n years, then the book value at the end of the nth year can be thought of as the implied salvage value. And that's what he's doing here in equation 12.9. As an example, suppose we have an asset that costs $80,000 to get it running. Purchase price, delivery, installation, whatever it takes to get it going, $80,000. And our recovery period is 5 years, and we estimate the salvage value at the end of the 5th year to be $10,000. And the question then is, find the depreciation and the salvage value for t equals 1, 2, 3, 4, and 5 for 150% declining balance, and then find it for 200% or double rate declining balance. So for 150% declining balance, little d in these formulas up here is 1.5 divided by n. N is 5, given in the statement up here. N is 5. So 1.5 divided by 5 is 0.3. And then as part B, we're saying find it find these values, the book value and the depreciation for each of the 5 years using this double rate declining balance, 200%, where D is equal to 2 over N, which would be 0.4. So these two columns in table 12.1, these two columns deal with 150% declining balance. This is 150% declining balance. And this is 200% declining balance, or double declining balance, called DDB, double rate declining balance. So when D is 0.3, that means according to let's see which equation. I think it's the first one. According to equation 12.5, whoops, excuse me. According to equation 12.5, the depreciation in year T is D times the previous year's book value. So that's what the author's using. Now, we use equation 12.5 if we're going to get it for every year. But if we're only going to get it for one of the years under a declining balance, then we would use this equation, 12.8. But for this one, since we're going to generate a table and get the depreciation for every year, we're using equation 12.5 for the D column. And for the book value column, we're just going to take the previous book value and subtract the depreciation to get the new depreciation. So let's start at time 0. When we first install the equipment, the book value is B, okay, which is BV sub 0 is B, and that's $80,000. Well, the first year we get to take 30% of that value as the depreciation. So that's 30% of 80,000 is 24,000. So if we depreciate 24,000, what's the remaining book value? It's 56,000. This minus this equals this. Okay. Now the book value is 56,000 at the end of year 1. So how much depreciation can we take in year 2? Well, we can take 30% of 56,000 using equation 12.5. So when we do that, we get 16,800. Well, what's the book value then after you take this 16,800 worth of depreciation? You have 56,000 minus the 16,800 gives you 39,200, and so on down the line for 150% declining. You do the same calculations, only now the depreciation is 40% of the previous book value. So 40% of $80,000 is 32,000. Subtract the 32 from the 80, you get 48, and then 40% of 48 is 19,200. You subtract the 19,200 from 48, you get 28,800, and so on down the line. And notice that at the end of period 5, using this method, you may or may not get down to this estimated salvage value. In the double declining balance method, you do when little d is 40%, but in this method, you don't. You don't get there. Sometimes you overshoot it. In other words, you could have a number less than that $10,000. Well, it would have been less if I had estimated, say this was estimated to be 20,000. Well, there's no S in any of these calculations. Okay, so these calculations are going to be done regardless of what you estimate the salvage value to be. Okay, so let's do an example problem. And Suppose I only needed the depreciation in year 3 and the book value at the end of year 3. So then I would use equations 12.8 and 12.6. To do this table, we didn't use those particular equations because we were going year by year. But in this case, now we would want to use equation 12.8 to get the depreciation and as a function of B and D, okay, and 12.6 to get the depreciation as a function of B and D. The earlier equations, I'll go back to them, say equation 4 and, well, equation 5, you see this is a function of the previous book value, which I won't have if I only do 1 year. Okay, so anyway, D sub 3 using equation 12.8 is D times B times 1 minus D to the T minus 1. Okay, so that's D sub T. We want D sub 3. That's what I'm asking for. And I'm telling you that you're using 100% declining balance. Okay, 150%. And we should also say that n equals 5. We're really still dealing with that particular issue, okay? And so in the case for D3, it would be little d, which when n equals 5 and you're using 150% declining balance, is going to be 0.3. So d equals 1.5 over 5 equals 0.3. And B was $80,000. So we'll take 0.3 times 80,000 times 1 minus 0.3, which is 0.7, to the t minus 1 power. So it'll be to the second power squared. So once we crank through this equation, you can see that 0.7 squared is 0.49, and 0.3 times 80,000 is 24,000, so we have 24,000. That's the product of that, times 0.49. We get 11,760, and of course we can double check it back here. 11,760 is D sub 3, and then the other question was, what's the salvage value? I'm sorry, the book value at the end of year 3, and we would then go back to equation 12.6 to get that, and so BV sub t, where t is 3, will be B times 1 minus D to the t. So that's 80,000, that's B. 1 minus D is 0.7 to the third power. We crank through that and we get 27,440, and you can see that number right here. So this is a way to, these two equations, we can calculate a specific year's depreciation and book value. A couple more examples I'll run through pretty quickly here. KTT Chromatics manufactures transient voltage suppressors with high power surge capability. These problems were from the back of the chapter. The company uses the straight line method for book depreciation purposes. Newly acquired equipment has a first cost of $240,000 with a 3-year life and a $30,000 salvage value. Determine the depreciation and book value for year 2. So since it's straight line, the depreciation is the same every year. And so we have the equation D equals price minus book value divided by life, which is 24,000 minus the salvage value, which is 30,000. So that gives me 210,000 divided by 3 is 70,000. And then the book value, it's asking for the book value at time at the end of year 2 after you've taken the second year's depreciation. So you would start with the original basis, which is $240,000. You depreciated 70 the first year and 70 the second year, so that's 2 times 70 is 140. Take that from 240, you get $100,000 as the book value at the end of time 2. And of course, you can see then the third year we're going to take 70,000 depreciation then, and then our book value at the end of year 3 will be 30,000, which is what we estimated the salvage value to be. That works out when you use straight line. The book value at the end of the n years will equal the salvage value, but that doesn't work out with declining balance method. Okay, so one more problem really that will work. Problem 14 in the end of chapter 12. Equipment for immersion cooling of electronic components has an installed value of $182,000 with an estimated trade-in value of $40,000 after 15 years. For years 2 and 10, use double rate declining balance, book depreciation to determine the depreciation. So I want the depreciation in year 2 using double rate declining balance, DDB. That's 200% declining balance. So that means that D is equal to 2 over 15. I carried 5 decimal places in my solution. The author said just use 3, but I wanted more accuracy, so I used 5. And because you can see there's a 0.3333 infinitely, so to speak. From equation 12.8, d sub 2 would be d times b times 1 minus d to the t minus 1. So I plug into that. d2 will be equal to 0.1333 times 182,000 times 1 minus that to the t, which is 2 minus 1 power, which is 1. And so when I crank through that, I get $21,031. That will be the depreciation in year 2. And if I do that for year 10, then the power here is the only thing that changes. And that becomes, it goes from t minus 1 is 10 minus 9 now. I'm sorry, 10 minus 1, which is 9. And I compute that then to be 6,694. And that concludes today's lecture. And I will do another lecture. I'll call it 24B and post it with lecture notes. The next lecture will cover sections 4. And we're going to skip sections 5, 6, and 7 and cover section 8. So I'll cover 4 and 8 in the next recording. Thank you.